Hi everyone, my name is Marcus Hurt and I'll be taking us through a quick simulation of ARRT Connect in a ROS2 Gazebo world. So there's two packages that are included in our repo. The first is the Gazebo Worlds package that contains the competition world that we've been using in this class, and the spawn instructions for the waffle bot. The second package is the ARRT Connect package. That package contains the ARRT Connect implementation as well as the map representation that we use to find the path, and a controller so that we can run the path that is found with ARRT Connect. So here I'm just launching the Gazebo world first with the turtle bot, the waffle bot. So we'll see that come up, and it spawns based on a spawn config text file that we have in our package, so we can designate what position and orientation for it to spawn in. As you can see, it's the same competition world that we've been using in this class. That was just to keep things simple. The experiments you saw above, as was probably mentioned, also used this map representation, but just adjusted for different buffer sizes to get the environments that we wanted to test the ARRT Connect node in. So you can see the search for this path took under 400 milliseconds. It was pretty quick. Our path looks pretty decent. This representation does have a smoothing step included, unlike the experiments you would have seen before. That's just to make things a little easier on our control node. You saw those trees were pretty simple. So nice fast search, only 177 nodes in tree A and 137 in tree B. Now, once you close that visualization, the robot automatically starts moving. So we're moving at a slow pace, but a controlled pace for the controller. Just navigating a couple of corners here. Like I said, it's been smooth. The path has been smoothed. Each point is about 10 centimeters apart. When the robot comes within 5 centimeters of the next point, the controller moves on to targeting that point. The smoothing step we found made the movement a lot easier to watch. We still were able to complete paths without smoothing, but they looked very jerky and were not easy to diagnose of what could possibly going wrong, whether it was slipping in Gazebo or actually a problem with the path. So we smoothed and found it fixed a lot of our problems, as well as reducing the speed, fixed a lot of problems of slippage in Gazebo. But you still see every 5 centimeters updating that point, we're adjusting our orientation first and then resuming forward movement. You could do both at the same time, but just a very simple controller to demonstrate that the path is accurate. So 10 centimeter step size on those points, a 10 centimeter buffer between the robot and the walls, fast path planning, and we're going to go ahead and finish up this path with the last turn here. Overall, it's a very impressive controller. The speed and as you saw, it was a very effective path. So here at the end, we're just going to hit the last point, and then the controller automatically stops all movement, and that'll be the end point right there. So thank you for your time, and hope you enjoyed the simulation.